1 second, I just want to pull up the, okay. All right. Hi, everyone. My name is Wasti Khan. I'm a second-year Master's in Financial Engineering student, and I'll be presenting the Lehigh University Pennsylvania 100 Index project. This is an MFE capstone project, and it is about equity indices, construction of an equity index using industry standard rules and building a automated system that generates this index value every day and publishes it on a website. So equity indices, just a broad overview of index providers and their roles. Equity indices such as the S&P 500, Dow Jones Industrial Average, FTSE 100, Russell 1000, Russell 3000. They all are rules-based indices which represent a certain part of the economy. The S&P 500, for example, the most well-known, represents the top 500 companies in Pennsylvania. Index providers are the people who create that index. So Standard & Poor's has created the S&P. They have a team of people who work on creating and maintaining new indices, and then they build products on top of that that they can launch, for example, as ETFs, or license it out, or really license the data behind the index to generate a profit. They're significant because, as we've noticed, the growing number of products and the growing number of structured financial services is becoming more and more important in financial markets. And so knowing how to create indices, how to create products on top of indices is becoming more and more important. And that's really the purpose of this project. The goal is to create a index that represents the top 100 companies traded in Pennsylvania, and to build an interactive and automated system that showcases the strength of the Pennsylvania economy. The reason is Lehigh is located in Pennsylvania, and there's really no other reason why we picked that geographical region. It's more of an arbitrary selection, but one that works for our purposes. The objective is to represent the state of the PA economy through one number and give an in-depth view of the state through the analytics and the underlying sector weights. It's a similar project to the one by the University of Miami, except this one is more student-led, is what I would like to say. In terms of the process, the first stage is the data integration and index construction. This involves obtaining the list of tickers. That is the 100 companies that are going to be the constituents of our index. And we use the same rules as the Russell 3000 plus one rule, which is it also has to be headquartered in Pennsylvania. And so you can think of the Russell 3000 as a universal set and our PA 100 index as a subset of the Russell 3000 index. This list is updated annually because the Russell rebalances annually. We also obtain the number of floating share counts for each company from their public filings. And we obtain the daily stock data, which we get from a licensed exchange. We will talk more about that later. So we get the tickers, we get the stock data, we put them together, and then we get the floating shares, and we calculate the free float market capitalization, and we automate this entire process. We also, after calculating the market cap change, we calculate the index level, and we perform data checks, which are also automated to make sure there's no changes in the ticker list, if anything has gone missing, if any company has been delisted, or if there's any missing data. All of those give us warnings before the publication of the index level. A little bit more about the free float market cap methodology, and I can show the code version of this as well. This is an example of how the S&P 500 is calculated. The S&P 500 free float version is calculated. There are more versions. There's the equal weighted and other versions of the S&P 500 as well. But the thing on the left here, the PI represents the price of the security I, or the ticker I, on date T. And the Q is the number of free floating shares of ticker I on date T. Now this is largely constant for each I, for at least for a year or a quarter. And the P is the thing that is changing every day. The price is changing every day, and that's the closing price And then when we sum all of that, we get the total market cap for each day. And I will show you the table in the code. And then we apply a divisor to it, which is a trade secret. No one will ever explain how they calculate their divisor, but it roughly follows a sort of smoothing factor. It depends on what the divisor is willing to accomplish. And the free float market capitalization method is important because this is the method that most accurately reflects the strength of the PA economy. Because if we used a total market capitalization method, we would be taking into consideration, instead of free floating shares, outstanding shares. Now, the total outstanding shares may not be the number of shares that are available for trading every day. There are reserved rights. There's a bunch of different reasons why some shares are not traded from the outstanding shares. Executives hold certain portions of the shares that are not available for trading. So free float really represents what the public is able to trade. That value is what's changing every day. Here we have a screenshot of the actual data table that is generated by our automated calculation engine. On the left, you see an ANSS, that's the ticker, and there's 99 other tickers to the left of this. This is only a partial screenshot. As you can see, there's like dots. So those are all the other tickers that are not represented here. And then the ones on the right are the actual calculation engine results. So this gives the percent change in market cap, the closed market cap level, the adjusted market cap level, the closed divisor, the adjusted divisor, and then the index levels, along with a null check, which checks if there's any missing tickers. So the divisor was introduced to adjust for changes in the index based on non-price factors. So if we have a company dropping out, a company getting delisted, a company getting merged, a company getting acquired, a company going through a ticker change, all of these things are non-price changes, and they should not be reflected in the index level. And so we can see on the yellow highlighted line here, if we have a company drop out, for example, in this case, the false goes to true, which means there is a company that drops on this date. The closed index market cap and the adjusted index market cap will be different. And the adjusted index market cap, the unadjusted market cap takes into account the company that dropped out. That results in a divisor value based on this index change level. And you can see that the divisor level changes between the close and the adjusted. It goes from 1 to 1.000935. That is because of that index change. Then we have the close index level and the adjusted index level, and those should be the same. So that is what this is trying to accomplish, is that even though we have a market cap change that has a non-price change, the index level remains the same. Now there's more details in the code that I will get to later, but that is the main function of the divisor, is to smooth it out. And you can see that the total market cap on the left and the index level on the right, they are exactly the same. The movement, the percent change is exactly the same. Obviously the levels are different. The total market cap is 1 point something trillion when it starts, and the index level starts at 1,000. So that's just to make it more the digestible number. What have we accomplished so far? So we switched our new data source. We moved to SIBO, who we now have a licensed agreement with to give us end of day market data. And we automated this daily feed into our index value generation through the calculation engine. And we created functions to do all these calculations and visualize the data into a graph, as you saw before. And we also are developing a website that's been designed by students as well. So the purpose of the new website is to make all the information relevant to this project, bring it all together into one place, and really make it a product, and allow people to discover more about the work that Lehigh students are doing in the MFE program. And this is one of those examples of student-led projects that are creating real products and interdisciplinary research through collaboration. So this is a screenshot of the website. I'm going to show the website later on, so I'll just skip through this. And then at this moment, we're on the verge of launching the website. In the future, we want to create more content related to this PA index, and publish it in local news media, reach out to government agencies that may be interested, like the PA Chamber of Commerce, automate the feed and update the quarterly floating share counts. We want to also create new analytics and visualizations, compare the returns of this index versus, for example, S&P 500, look at the underlying sector weights and how they change over time. And we want to add this new page into the website. That's the end of the presentation. I'm going to go into the website itself. This is what you saw right before I ended. It's the
Hey,
website.
Wesley, just one question. How long has this project been going on?
So this project has been going on for over 2 years now. Before me, we had a bunch of other MFE students, Ramos, Wu, I think Matt, and others who started the project. I've been involved for the last 1.5 years. And honestly, going from learning nothing about indices to building indices and potentially working in the index provider industry, it's really been the project that has given me the most, at least, and I've given it a lot. So it's a continuing project, and I hope that it continues to grow and build and branch out into new things, because the index industry is not just about equity indices now. There's other indices that we could be building, looking into, and I think there's a lot to learn that's not done in the classroom. And that's the biggest takeaway from this project for me, because this is all I talk about. I don't talk about what classes I take. I don't talk about what academics I'm doing. So this
Great.
really.
Okay, you could continue.
So this website now shows the description of the index and a graphical representation, which you can zoom into, pan, and do a bunch of other things. And then the sector weights. So if you hover over each of these, you'll get the sector name and the market cap of that sector. Like basically the proportion of the index that is represented by each sector is displayed here. We didn't add a legend because there's a bunch of sectors and we don't want to overcrowd this plot. So you can just hover over it and look at what sector it is. So here you can see it's industrials. Then we go into the details about how the index is calculated. Eventually, we'll also add documentation about the exact procedure, because that's the industry standard. We go into the index construction in our methodology page, the selection criteria, the company list, and you can see what companies are listed. So you can see Comcast, Air Products, PNC Financials, Services, and the sector and the industry to which they belong, along with the most recent market cap of each company. And we have a page for the team, which is dynamic. Every year it'll change. Right now there's my face on it, but soon there'll be somebody else's face on it. Then we have a link to the MFE website, which again has my face on it. But this is really to create that link between, okay, these are the people who designed and created this product, and this is where they learned it. Then there's a contact page that people can send emails to. There is a dedicated email address that has been assigned, and it goes directly to that email.
Very good.
Going to go a bit more into the code. This
Yes,
is
please.
the daily script that runs. It's called Run Daily right now, but we can call it whatever we want. What this does is it creates a bunch of functions that connects to our SFTP, which is the SIBO subscription. It gets the data, and you can see here it's commented so that it explains every single step. It finds the most recent zip file with underlying EOD in the name. It extracts the zip file, gets the CSV, reads in the data table, and then displays it. I'm going to skip over that part because it has some sensitive information, such as the login information, and I can't show that on a video. So I skipped over that part, and then what it basically does is it goes in and deletes the CSV because we don't want to store 100 days worth of data. It then takes that data table and does all this calculation in it, which is all just really column, basically like linear algebra almost, just multiplication though, nothing too complicated, multiplication and division, and calculating the index level. And in the end, we get this table, which is what I was showing before. So we get this table where the columns are all tickers and the rows are all dates. And so we have all these tickers, and at the end, we get a closed market cap value. And then we do that same thing I showed before, which is the adjusted divisor, closed divisor, adjusted index level. And this index value is the adjusted index level. So right now we have from October all the way to yesterday's data, it should be, or a few days ago. And then this is the most recent data table that we actually have. So we have equities data for like 11,000 equities, but we're not using all of those. And then it saves it into a file that goes into this Flask application, which will then display it on the website as you saw. So the Flask application is really just a web application function, and it'll take the output of that script and put it on the website. So it's basically like sort of like plumbing, just connecting one part of the project to another. So yeah, thanks. And if you have any questions, you can head over to the website and send us an email.
Thank you.
All right, thank you.